Alrighty, everybody, good day. Let's get started. So I know the homework was a real pain in the butt. I hope you did the best you can on it. Now I'm going to be very, very forgiving on the word problems. I know the word problems take a lot of time to set up and be difficult to do. So if you did your best and got anything right on them at all, you'll probably get full credit for your word problems. And as long as you got the ones done that weren't word problems, you're probably going to be fine. Now, today we're going to take a step back and we're going to go back to systems of equations. But we're going to do it. It's going to be a nice break because that last one was a painful thing. Let's get that out of our palates. And we're going to study how to solve 3 equations with 3 unknowns. It's really not that complicated. I think you'll be fine. But let's practice this one more time. So here's your warm-up today. They give you these 3 restrictions. So this is where the boundary will be. We'll use them to shade things in. And we're trying to find the max and the min value of this function, f of x, y, at one of the vertices. So let's graph this. And again, I tried to make one in the warm-up today to be the speed of the extra credit on your test. When the test comes, your extra credit will be one of these problems, and it shouldn't be that complicated. So let's see if we can graph these, okay? So right at the bat, number 1, y is less than or equal to negative x plus 2. Well, negative x plus 2, what's that look like? It's a line. Should know that from Algebra 1, and we studied it already. Y-intercept's 2, right? So it starts up here, 2. Fill in something at 2. And it's going to have a -1 slope, meaning it goes down 1 every time I go over 1. So down 1 over 1, down 1 over 1. And that's a greater than or equal to or some kind of thing. So it's a solid line, less than or equal to, I guess. And that's what that one looks like, which we'll be shading below, correct? Okay, that one's cool. Now, what about x is greater than 0? Well, what's the graph of x equals a number look like? That's a vertical line. Very good. And where's x0? That'd be right here, correct? So this is a line straight up and down. It is actually the y-axis. The equation for the y-axis is x equals 0. So here's our second inequality right there. And we'll be shading that. We want more than that. So we'll be shading to the right of that. So far, I am below this. And to the right of this little triangle here is my region thus far. The last one, y is greater than x. Well, there's no y-intercept, so the y-intercept is 0. And the slope is 1, so I'm going to go over 1, up 1, over 1, up 1. That was a point I already had. So there's this one right here. And if you look at all the regions, it's got to be below this line, has to be above this line, and to the right of this. It actually turns out to be just this little tiny triangle in here. This is the region I am going to be studying right there. It's got 3 vertices because it's a triangle and it's got 3 vertices. Makes sense. The coordinates are pretty easy to spot. This one's at the origin, so it's 0, 0. This one's 2 over, so it's at 2, 0. No, it's not. I don't care about that point. What am I talking about? I don't care about that one, do I? I care about that one. Where is that? Looks like 1 over, 1 up. So 1, 1. And this one here is 0 over and 2 up. So I got all my coordinates of the things around the boundary. And all you got to do is plug them into this, right? See which one's the most or the least, and we're good. So let's try 0, 0. When you plug 0 in for x and 0 in for y, you get, well, anything times 0 is 0, right? So 0 plus 0 is 0. That one gives me out 0. How about the point 1, 1? Let's get that one over with. Plugging 1 in for x and for y, that'd just be -5 plus 7, which would be 2. And the last point, 0, 2. If you plug 0 in for x, then this doesn't matter. And all I have is 7 times y, which was 2. And 7 times 2 is 14. So where's the max? 14 is the max at the point 0, 2. And the min would be the smallest number 0. So there's a minimum value of this thing I'm studying at the origin 0, 0. And that's about it. Think you can get through that on your extra credit? I think you can get through that, yeah. So if you absorbed all that, you're okay. And let's go ahead and jump in with some LGs and get ourselves to work. Oh. That's Belinda Carlisle. She's saying heaven is a place on earth. Do you know that song? I think she's pretty. Isn't she pretty? I think she's pretty. Thank you. There you go. LGs. Yeah, she's right over there. Yeah, she's everywhere. I adore her. I think she had a Coke problem. Don't we all? Yeah, touche on that. All right, learn how to solve a system of 3 equations and 3 unknowns. And if you can do this, you could do 4 equations and 4 unknowns or 5. It's just tedious. It does take some work. The concept is easy. It's not going to be like this last section at all. Back to good old substitution kind of stuff. The only thing that's going to get you in this is if you're not being organized with your work or you make some dumb little mistake. Dumb little mistakes will always get us. You say 5 plus 8 is 12 somewhere in your work, well, then that's going to trickle through everything else and jack everything up. So you want to be very meticulous and careful on this one. All right, the horrible thing is due today, so get that done to the best of your abilities by the end of the day. I'm going to comp you a lot of points on that one, so don't sweat, don't stress. Don't think you got an F, you didn't. As long as you did something, you're fine. New one out there, 2.8. That'll be due on Monday, and let's go ahead and start going with the notes for today. We are doing section 2.8. We're getting close to the end of this unit. Every one of these units has a lot of stuff in it, doesn't it? Test will be coming up soon. Not this week, not next week, but probably the Tuesday after that or something. I want to give you guys a lot of time to review, and I want you to have a lot of time on that study guide. I think by far, if you get the study guide figured out, you will be fine on the test. It's that simple. If you're just getting the answers from somebody on your study guide, you don't understand it, you're screwed on the test. But if you really get through that study guide, you really understand every problem on there and study it, there is no reason you won't do well on the test, because it's the same thing. All right, let's get going. I'm going to go off script for a second. Just as a concept, let me introduce where we're going with this today. And you don't have to write this down, just think with me. We were doing things like this, correct? System of equations, right? What 2 techniques did we have that were the best to solve these? Substitution and elimination. Good. We can still use those. Now, just as an idea, this is a line, correct? Right? Or whenever so there's a line here and there's a line there. Now, a line, does anybody know what dimension, this is seemingly off topic, a line is? It's not 2D. 1D. It's 1D. By dimension, I mean it can go left or right. That's one direction. It can go along one axis. Fair enough? So whenever you're graphing things that have x's and y's, well, if I graph something else with x's and y's, say y equals x squared, it's a curvy line, but it's still a line. Yeah, it's curvy. And if you straighten it out, it'd still be what? One dimensional. So these graphs turn out to be one dimensional. Fair enough? Now, I can't draw it on a line, though. I need to draw it on a plane. See this here, this whiteboard I'm using all the time? I have to draw it on a flat surface. So you graph these things, graph on something that is 2-dimensional, x's and y's, right? You plot them somewhere, you're living in 2-dimensional space, and you got some curvy thing that's 1-dimensional. Fair enough? All right, let's go up conceptually level then. What happens if all of a sudden they start adding a 3rd variable? Something like this. Well, I just went up a variable. Guess what happens to all these things dimensionally? They go up a level. This thing, these graphs, they would not be 1-dimensional things. Guess what they would be? 2-dimensional. What's 2-dimensional mean? It means it's like a plane or something like that. So these are actually kind of, if you graph these wouldn't be lines, they'd be planes out in space. Maybe they're curvy or something like that, but they're flat. Fair enough? And you have to graph this. You can't do it on a flat 2-dimensional thing anymore. You got to go to 3 dimensions. So how do you draw a plane? I can't just have an x and a y. I got to have a z too. So I have like a 3-dimensional thing. So what this is all going to summarize to is when you are doing systems of equations like this, geometrically, what that means is it's going to look something like this. And you don't need to jot it down, but just think about it for a second. Don't worry, you're not going to visualize this at all, but I just want to expose you to what it is. This graph is a plane. This graph is a plane. This graph is a plane. Could planes intersect? Yes. So they could intersect in a line, or they could intersect at a point, or is it possible for them to not intersect at all? Yeah. So old buzzwords again. What's it? What's the word for there's a solution? Does anybody remember? Fancy word for there's a solution? Consistent, right. Is this consistent? Do they cross somewhere? Yeah. Is this consistent? Do they cross somewhere? Is that consistent? No. So it's the same concepts as before. It's just going up in space. And what you're actually graphing is a plane instead of a line. Now, you don't need to know that. Let's dive in and just see how you would approach these problems. So here's your notes. I'm going to go off script. I want you to avoid confusion. I would like you to use the method of substitution. It gets a little tricky with elimination, so let's just avoid that altogether. So I want to go ahead and solve this. Write down this example, and I'll just show you as we go. It'll make perfect sense. It's going to be very important. This is why I've always been numbering my equations. I only had 2 up to this point. Equation 1, equation 2, equation 1, equation 2. What's the point of numbering them? Well, right here. When we start having 3 equations or 4 equations, it's extremely important to know what I'm working with. So let's copy this thing down and then take it from there. It's really not going to be any harder. Just takes more time. All right. Here we go. Patience is the key. Okay, forget that there's 3 variables. If I say do by substitution, what do? You solve for something, right? And you plug in the other one. All unit long, I've been saying plug in the other equations on purpose because I knew that someday there'd be more than 1 or 2 or 3 equations. So again, just start with what you know. Guys, what looks easy to solve for? Any letter in any equations that look easy to solve for? What? Why? Which equation? All right, so that's what we're going to do. Just like substitution is the same thing. We're going to get one thing by itself. So equation 1, we're going to get y by itself. Y is, and you'd move the 4x over and the 6z over. That would make them negative, correct? Negative 4x minus 6z plus 12. Why do you get something by itself with substitution? So you can substitute it into the other ones. Now, this is why it's important to have things numbered. You solve for this in equation 1, correct? That means you need to substitute in the other ones into equation 2 and into equation 3. It just takes a little bit longer. It's not that bad. So let's do that. Substituting this into these other 2 equations, here we go. Equation 2 is now 2x, right? Minus 10, oh, there's y, but we're going to write this thing's, right? Make sure you use parentheses and stuff like that. Negative 10 times this whole thing. All right, there's 2x minus 10y minus 2z. Keep copying. Make sure nothing disappears. Make sure no signs change. We're good on that. Well, you got to do that one too. I got to substitute in all the other equations. So equation 2 is done. Now I got to do equation 3. Equation 3 is 3x plus 8y, which again is negative 4x minus 6z plus 12 plus 19z equals 38. At this stage, it's very important to see what's conceptually happened here. Just like with any substitution, we usually have 2 equations, right? 2 unknowns. We substitute into 1, and then we get down a level. Now it's down to 1 equation and 1 unknown. Well, what happened here? You had 3 equations with 3 unknowns, correct? You solve for something, you plugged in the other 2, and now you're down to 2 equations with how many unknowns are there? How many different letters? 2. You made progress. It's not 3 equations and 3 unknowns. It's 2 and 2 unknowns. So we will proceed to solve this one like normal. But first, this is an ungodly mess, isn't it? Let's take a second and clean this up. So probably the next step after this is just clean crap up. Let's just kind of simplify this thing a little bit. All right, I'm going to try to do it all in one shot. Ready? Set. X's. Would you agree that there are 40 x's from this distribution right here? And I also see 2 x's, correct? So 40 x's plus 2 x's is 42 x's. How about z's? I see 60 here. Do you see 60 z's? If I distribute this out, what would this be? These two. 40x plus 2x. So I'm kind of distributing and putting things together in one shot. Z's, 60z, right? But I also got a minus 2z. So that'd be 58 z's. Okay, we did the x's, we did the z's. How about just straight up numbers? Any just numbers floating around here? I see negative 120 here. Do you see negative 120? What are you going to do with the negative 120? Probably add it to both sides, right? So you can put it together with 12. So if this is negative 120, and I add 120 both sides, what's 12 plus 120? It's 132. Isn't that much cleaner than before? This is why you want to take a step back and clean it up before you even proceed any further. And the same thing we're going to do on number 3. How about x's? Well, from this distribution, do you agree that there's negative 32 of them here? Negative 32 x's plus 3 x's would be negative 29 x's. How about some z's? Well, from this distribution, I'm seeing negative 48. But then I'm adding 19. So I got to figure out what negative 48 plus 19 is. Turns out to be negative 29 again. And as far as straight up numbers go, I see 8 times 12 here. That turns out to be 96. I don't want 96 on this side. I like to move to the other side. So subtract 96 from both sides. 38 minus 96. I don't want to chance it. I don't trust my brain at the moment. 38 minus 96 is negative 58. So if that was too much to do in your head at once, that's fine. Distribute it out. Take an extra step. There's no problem with that. All right. Now, brand new problem. None of this crap ever happened. I don't worry about that. Look at this fresh. How do you want to solve this thing, guys? Substitution or elimination? Anybody got any suggestions? I would go elimination on this one because guess what 2 times 29 is? 58. So I'm going to use elimination on this one. And let's go ahead and multiply this bottom one through by 2 first. So keep working it. Equation 2, we're not going to change it. 42x plus 58z equals 132. And equation 3, we decided to multiply everything through by 2. So negative 29x times 2 is negative 58x. This would be negative 58z. And 2 times 58 is 116. Yeah. All I did was multiply this bottom one through by 2. Everything by 2. 2 times 29, 58. 2 times 29, 58. Well, because what's twice of this? It's 58. So I'm trying to force them to have the same number in front, because that's what I need for elimination, right? Now, should I add these to get the z's to be eliminated or subtract them? Add them or subtract them? Add them, yeah. So we're going to add these together. Let's add these two together. 42 plus negative 58, negative 16. Negative 16 x's. The z's added together is nothing, correct? And over on the right side, 132 plus negative 116 is a positive 16. And then if you divide both sides by negative 16, finally, we figure out that x is negative 1. Took a long time, but we finally got one of them. How many do we need? How many letters were there? 3. So we got to go back, just like with any substitution. Once you get one of them, you got to go back up the chain, plug it in somewhere to find the other ones. Well, I got x. Doesn't matter which one I use. How about this one? If I plug it in here, what can I solve for? I can solve for z, right? So let's do that. Doesn't matter which one we pick. I'm going to go back to equation 2 now. So equation 2 was 42x, but x is negative 1, right? So 42 times negative 1 is negative 42. And then the rest is still there. Plus 58z equals 132. So just plug in -1 into that equation right there. And solving for z, we'll add 42 to both sides. So 58z's is 174, if I added that correctly. And then dividing by 58.
3.
I hope it's pretty. It is. Yes, indeed. So z is 3. So now I've got 2 of them. I got x and z. We'll plug it back in somewhere up even higher. Probably the substitution I made in the very first beginning was a good spot to go. It says y equals this stuff. So let's see. Y equals -4x. X is -1. -4 times -1 is +4. Minus 6 times z. Z is 3, so -18. And then you got a +12 here. And when you go simplify all that, you get -2. So there is my solution to this system. 3 variables had to be found, x, y, and z. We got them all. Now, old stuff still applies. Did you get answers? What should you write? Consistent. Write the word consistent. Did anything weird happen in your work, like 0 equals 0 or 5 equals 9 or anything weird like that? Nope. So consistent, and what's the one we usually write? Independent. Yep, still consistent and independent here. This one up here. This one right here. Yep. But it doesn't really matter, right? I could have plugged in here, could have plugged in here, could have plugged in here. It didn't really matter. Any of them would have got me the same answer had I followed the rules. So I know it's a lot of work, but let's take a step back. What was the process again? Solve for one thing, right? Plug in the other ones, correct? And after you clean them up, now you have 2 equations with 2 unknowns, right? Solve that like normal. I don't care what you do. Substitution elimination. You'll get one of them. Plug them back up the chain. Eventually, you'll get back to where you started. Let's try one more. Example 2. Last one for the day, if you get the idea. If you want to see more examples, I'm happy to keep going. Something tells me you won't want that. Call it teacher experience or woman's intuition or something. Nice and slow, nice and slow. Write down all 3. -4. That was a lot of distributing. That was a lot of being careful with numbers. You see how if we messed up one little part of that last one, all that work would have been useless. So you really want to be double checking that every step is correct when you're doing these, or else everything is going to suck. All righty, let's go again. Start off substitution. You got to solve for something, right? You guys pick what looks easy to solve for. Bottom one, what do you want to solve for? X, Y, or Z? Okay, let's solve for X. So equation 3, we're going to solve for X. Let's take a second and do that. First, you'd probably start by moving the Y and the Z to the other side, I would assume, correct? But then we don't have X by itself. We got -X. How do we fix that? Yeah, divide or multiply everything through by a negative, right? So if I multiply this by a negative, it's positive. And then basically I'm just changing all the signs, right? Change the sign of this term. I'm going to change all these signs. So this -Y minus Z plus 1. All right. So if you solve for X in equation 3, you need to plug it in for X in equations 1 and 2. So that's what we're going to do next. And this is a pointless bunch of arrows. I'm just saying I'm going to plug it in there for you guys. All right, here we go. Equation 1, plugging in that for X. First it said -X. So negative up, but what's X? X is now that junk, right? So -X, X is -Y minus Z plus 1. There's -X. And the rest I'm just copying. Plus 5Y minus 4Z equals -2. And in the exact same fashion, we're going to plug it in for x in equation 2. That was 4x. So you're going to write 4 times what you're substituting in for x, or x. And the rest is copying. Minus 20y plus 16z, and that is equal to 8. So we've accomplished something. We don't have 3 equations and 3 unknowns. After you did the substitution, now you're down to 2 equations and 2 unknowns. Better, but an ungodly mess right now. So let's take a second and clean this crap up, because this is just gross. All right, we're not doing anything on this step but cleaning. We're cleaning. Here we go. I see y's and z's. Let's go in that order. Up here, if you distribute this negative, you have a negative y. That's just y, right? So there's a y plus 5y would be 6y. Check. How about some z's? Well, again, I see a negative z. That's z, right? And z minus 4z would be negative 3z. Don't forget the numbers. What number do I see? The only number I see over here is a -1. Would you agree? -1. Well, I don't want that on this side. I'd like to move to the other side. So let's add 1 to both sides. Adding 1 to this side and adding 1 to that side would make this -1. -2 plus 1 is -1. That's a lot better. Equation 1 looks so much prettier now, right? Let's clean up equation 2. Okay, y's. From this distribution, I see -4y, correct? -4y, but I also got a minus 20y. That's a grand total of -24y's. Z's, -4z here, right? -4z plus 12 or 16z would be 12z. And as far as numbers go, 4 times 1 is 4, right? But I don't want this 4 over here. Let's subtract it on both sides. And 8 minus 4 on this side is 4. And if that step's too much to do all in your head, distribute it out. Combine like terms, you'll get the same stupid thing. All right, looking at it fresh. Brand new problem. It's like the rest of this didn't even exist. If I give you this problem on the test, what do you want to do? Substitution, elimination, what do you feel like? Elimination. What do you want to eliminate? Let's get rid of some z's. All right, so I got the numbers in front of the z's to be the same, right? Well, I could just multiply this by 4. Wouldn't that work? So let's multiply the top equation through by 4 and see what happens. Oh, you guys see ahead? What's going to happen here? Multiply by 4. We're not going to change this one, though, right? All right, so how would you get these to eliminate? First of all, you'd have to add them, correct? So if you add everything, well, what's 24 plus -24? Nothing, right? -12 plus 12 is also nothing, right? So this side has nothing. Over on the right, -4 plus 4 is nothing. Now, do you remember how to interpret this? It did come up before in your work. That means a freak thing, okay? I mean, it means there's an infinite number of answers. What's that? Consistent and dependent, remember that? Consistent and dependent. Or there's no answers. How do you know which one it is? Well, yeah, the no answers is something wrong. So if I got 0 equals 5, you would say that there's no solution, wouldn't you? Or what's our fancy word for that? Inconsistent, remember that? But if you get something that's always true, that means that these don't just cross, they cross at an infinite number of spots. So the answer to this is consistent. There's answers, but they ain't independent. They are dependent. So the same rules apply as when you did it with 2 equations and 2 unknowns. It has the same result. You don't need to write any specific answers for that because there's an infinite number of them. So why even bother, right? Get the gist? Okay. Well, one more time, what did we do? It was the first thing we did. Solve for something, right? And whatever equation you choose to solve in, you got to plug in the other ones, right? So if I solve for something in equation 2, you plug into equations 1 and 3, right? If I solve in 1, I plug it in 2 and 3. And once you substitute it in and clean it up, you're back down to just a normal problem, right? Solve your normal problem, If something weird happens, it sucks, interpret it correctly. And if it doesn't, then you got an answer, put it back up the chain, and you're good. And that is your lesson for today. Tedious. Watch the little things. One number is wrong, whole thing's jacked up.